Hello everyone, and welcome to today's webinar, Protect Your Project Management Applications from Common Attacks. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You're listening and using your computer's speaker system by default. If you prefer to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. In order to make this a more dynamic webinar, we encourage you to please submit text questions to today's presenter via the questions pane on the control panel. You may send in your questions at any time during the presentation and we will answer them during the Q&A session at the end of today's webinar. Please also note that the presentation is available for download via your attendee control panel. You will also receive a recording after today's webinar. On the control panel is also a handout section with additional supplemental material. Now I would like to introduce our speaker today, Cameron Vixie, LoadSpring EVP of Engineering and Technology. Cameron has more than 13 years of technical and management experience in computer technology and data center operations. Before LoadSpring, he handled enterprise information services implementation for NMCI. He also oversaw IT operations for RazorGator Inc., architecting and implementing their IT infrastructure and day-to-day operations. Cameron holds a bachelor's degree in computer science from Walla Walla University. Now, Cameron, please take it away.
All right, thanks, Christian. So today I'm going to talk to you about the common types of attacks that we see and some of the ways that we protect against those types of attacks. So today what we're going to be going over here is we're going to talk about the common attacks, which are SQL injection, cross-site scripting, brute force, denial of service, SSL vulnerabilities, and ransomware. So in doing some research for this, how big is the threat? There's quite a few different security vendors out there and they all have different metrics, but what I was able to put together is that taking just one of those security vendors, they saw over 63 million attack attempts in just the last week. 17 million of those were directed against the US, 10 million against Canada, which are two of the major regions that we operate in. So this is a major threat. In the US alone, estimates are that over $100 billion is lost every year to hackers through paying for the security as well as exploits as well as recovering from attacks. So it's really a big challenge for every technology company on the planet today, or every company, I should say. And it depends on what industry you're in for what types of attacks are commonly sent against you. So the common attacks, that we see out of these top 5 are SQL injection and cross-site scripting. So I'm going to go into the first one here in SQL injection. So what is a SQL injection attack? A SQL injection attack is a technique that's used to attack usually a database-driven application. And the way that people will exploit a SQL vulnerability is through they will execute SQL statements against the application and see if they get input back. Once they get that input back, then they'll execute specific statements, and those statements will allow them to extract data or inject data into the database. So they may do something simple. Will they say, if 1 equals 1, then do this, and so that would allow them to either pull table information or inject table information, depending on what type of SQL vulnerability is there. This gives them the ability to they can spoof a user's identity. They can, like I said, tamper with the existing data or expose it. And we've seen a couple examples of this here recently. One of the big ones from a few years back was Barracuda Networks, which ironically, they are a security vendor, and they are actually, they develop a number of products specifically to test or protect against this. And when they had been hit by a SQL injection attack that exposed a bunch of their users, their user passwords, and confidential information from people who had purchased their products, one of the key things, they tried to expose a lot of the things that they had done wrong in an attempt to build their credibility back. And one of the things that they had done wrong is that they had turned off some of their application firewalls that were protecting them against this. Another example is in the 2016, the election the ballot polling information in Illinois was hit by a SQL injection attack. And through that attack, the attackers were able to expose the personal information of over 200,000 voters in Illinois. So this is definitely, it's a risk to the confidentiality of your data, and it's a risk to the integrity of your data. So what does LoadSpring do to protect against this threat? Well, we talk about a lot internally having multiple layers of security, or an onion of security, right? Because there's no one thing that's going to prevent an attack from being successful. Attacks are changing constantly. Every day, attackers come up with a new way to exploit things. So it's always difficult to stay a step ahead of the attackers. And so we put multiple layers in place to not only protect against attacks, but to protect against common mistakes that people can make in day-to-day life. So one of the top things that we do is we do penetration testing, both with ourselves, and then we contract with third-party vendors to test and validate our applications that we write, as well as the third-party applications that we host. And those give us ideas of what vulnerabilities exist. Are there patches for that in the event of a third-party vendor? If it's the LoadSpring platform, then we work to close any of those vulnerabilities. Another way that we protect against that is we have certain customers that will only allow connectivity to their applications over an MPLS, which is a dedicated network that specifically goes from their offices to our office, and they restrict general internet access to any of those applications. So that's one way that they protect against it. Obviously, staying on top of patches and making sure that all of your patches are up to date is critical to maintaining that. And then we also do direct access prevention. And what this is instead of every application being assigned directly to an IP, you have to know the URL of that application. And why this is important is that we see people running random scans against all of the IP addresses that LoadSpring owns. And through those attacks, they're able to run checks for vulnerabilities. So if we're hosting for some projects an older application that may not be up to date with, or not up to date, but it's the vendor has not provided a patch for a vulnerability for that particular application, it's critical that we have other layers of security in place to protect against that. And we see that particularly in the construction area, where a particular version or a particular application has to be used for the life cycle of that project.
Thank you, Cameron. We're going to go ahead and launch our first poll here. All right, so how often do you perform a security audit against your project management applications? We'll give everybody a few seconds there to enter your answers. Okay, I see them coming in. A few more seconds there. All right, we're going to go ahead and close the poll now and share results. So our winner here is monthly audits and then annually with 33%. And then our second poll, how often do you review your Oracle patches? All right, we see the answers coming in. Thank you, everyone. We're closing the poll now. All right, we have an even answer here, monthly, quarterly, and annually. Okay, so thanks everyone for participating. We have 3 more polls coming along. And all right, take it away, Cameron.
All right, thank you. The next one that or exploit that or attack that I want to talk about here is cross-site scripting. So what is cross-site scripting? Cross-site scripting is a client-side code injection attack where the attacker actually injects malicious code into your website. So this'll be more common with applications that take user input, but it could be anything, right? We just saw this happen with Equifax, not the main Equifax exploit, but there was a secondary attack against Equifax where users who went to the Equifax website would download malware or this malicious software through visiting this legitimate website. And so what we see with cross-site scripting, one of the biggest risks is that either it allows the attacker to take the session cookie from the end user, and this would allow the attacker to spoof that user's session and give them access as that user into the application, or they can use the cross-site scripting to gain access to that user's credentials. And that user's credentials then would allow them to authenticate and act as a normal user, which would allow them to gain full access. So the biggest risk here, again, is to the confidentiality of your data, as well as to the integrity if somebody were to get access and start entering bogus data or things like that. So how does LoadSpring protect against this? Again, it's going to be a mixture of different layers, right? So we have penetration testing again, so we're often running cross-site attacks, cross-site scripting attacks against our websites to maintain whether they're vulnerable to those or not. And if they are, then we work with our vendors or we work with our own developers to protect against that threat. Layered security, so we have these multiple layers of protection in place so that the attackers can't get to sensitive information. And then again, MPLS or IP restrictions that restrict those users from coming to the applications. Patching and direct access prevention are really our keys to protecting against this, as well as several other things that I have covered here, such as our IP intrusion prevention system and our intrusion detection system if somebody's executing randomly. The next attack that I'm going to talk about here is a brute force type of attack. Generally, a brute force attack is not a software vulnerability, but it targets weak passwords or common accounts. You can detect it through an unusual spike in memory or CPU usage on the application, which also can be contributing to poor user performance. So if somebody's just hammering this application, it's going to impact the overall usability of that particular website. And the risk here with this one is, again, if an account is compromised, the attacker can impersonate the user, which gives them full access to the customer data. Or, you know, in one of the examples here with the Shire Corp had a construction manager who hacked in using weak username and passwords for the Department of Transportation in Rhode Island. And they logged into the Department of Transportation's database to get bid information from other vendors who were bidding against them on projects. And that gave them a very strong competitive advantage because they were able to underbid or provide information directly in contrast to the other people who didn't have that insider information. So they just arrested that guy here a couple of weeks ago. Another example of this is the target attack which happened against the Superstore Target here back in 2013. But in that scenario, the attackers were able to gain access to a vendor information and then use that vendor information to compromise an application that had elevated privileges in Target's network. That then allowed them to install malware on all of the terminals. And then through that malware on all of the terminals, execute a man-in-the-middle attack where they captured all of the credit card information for their customers, bundled that up, and then shipped that back to themselves. So there's a couple of things here that we can do to protect against a man-in-the-middle type of attack or the brute force attack. Pen testing does help us with detecting vulnerability. So if, for example, the accounts don't lock out after a certain number of attempts, that would be caught in our pen testing. That is a way to slow down the ability of an attacker to execute a brute force attack against that. The layered security that we talked about before, requiring complex and frequently changed passwords. So by requiring complex passwords versus simple passwords, such as password or 123456, we protect our customers against those types of attacks. Changing the default accounts. So commonly what will happen if you look at like an application like P6, they have these common accounts, priv user, pub user, and so on. Those accounts, you got to make sure that you change the default passwords because those default passwords are very simple, and then making sure that in any areas possible you actually disable those accounts and create your own accounts, or change the username for those so that they can't simply guess those. The MPLS and IP restrictions would apply again here as well. And then federated authentication is another way to make sure that those applications stay safe. So with federated application, what we do is, or authentication is, we connect to your on-prem Active Directory. You use your accounts to authenticate against your own systems in your network, and then that sends a token across to us that we accept. We generate a 64-character password randomly, and that's only valid for that particular session. So a brute force attack would be very difficult against a federated authentication environment. And then the other one is, again, the direct access prevention, so that people would have to know specifically the website that they're targeting versus being able to just scan randomly IPs and throw usernames and passwords against those.
All right, so let's go ahead and launch our third poll question. Do you leverage federated services with existing vendors? Right, see the answers coming in. Give it a few more seconds here. All right, we're going to go ahead and close the poll now and share results. Okay, so we have about even again, yes, and I'm happy with the results, yes, but I'm unsatisfied, and no, but I would like to. All right, we're going to close this now, and thank you, Cameron.
All right, thank you. All right, the next attack type that I'm going to talk about here is the denial of service. So denial of service is it's an attack by some attacker. Their goal is to take your service offline or prevent people from accessing your service. So the attack could happen directly against your data center, or it could happen against some critical piece of service like your DNS provider that Your DNS provider is what allows people to access your website by its pretty name, so like www.myloadspring.com. And if they're able to knock that offline so that legitimate users can't get that information, then they're not able to access your website. So the risk here is more on the access side, but a sustained denial of a service attack prevents legitimate users from accessing the applications. And this is something that we see across the internet, and it's something that's definitely getting worse, particularly with the Internet of Things. The Internet of Things is all of these things where you can hook your light switch, for example, up to the internet and control it through your smartphone. And it's really cool to be able to smartly control your house. The challenge is that a lot of those devices are not secured against attack, and they get compromised and they become what you call zombies. If you put enough of those together, you can create a bot army effectively that allows you to use the combined bandwidth of all of those people's devices that have been compromised and use that to push data into or against a data center. So a couple examples of this. We saw it this year, and we also saw it last year with AWS. We also saw it this year with DreamHost, particularly during the controversy where they were hosting one of the racist websites that was after the Charlottesville riots that we saw here this year. So with AWS, it was executed both against them and I believe last year it was against one of their primary DNS providers, and this impacted a tremendous number of applications on the West Coast. As you saw, how many people were using the AWS infrastructure and were taken offline for a period of up to between 4 and 8 hours, depending on the particular service. So how does LoadSpring protect against denial of service attacks? This is really a partnership between our ISPs and ourselves. So we have a bunch of devices in place that will automatically detect if there is a lot of traffic coming from a particular area that does not appear to be a legitimate user, and what it will do is it will shunt that off or black hole that. We also partner with our ISPs so that we can detect and black hole that traffic before it even gets to our bandwidth or our internet pipes and saturates them. And so what will happen in those scenarios is they will effectively just take all of the traffic that's coming from these bots and send it into a null route instead of sending it on to LoadSpring's services or services. The other way that we protect against this, again, is with the MPLS in particular. The MPLS being a dedicated network, it is not impacted by the internet attacks that would go against the primary websites. And so in the events where we have seen denial of service attacks taking place, customers who had MPLS networks were completely unaffected and remained online throughout the duration of those attacks. LoadSpring has not been targeted directly, but there have been times where we have been impacted by a denial of service attack that was directed against somebody else at that internet service provider or on that DNS service. And so we were able to quickly work with our vendors to mitigate that. And the duration has not exceeded 30 minutes in most cases. But if it is a concern, the best way to protect against that is with that direct MPLS connection. One of the next ones that I want to talk about, this one is in some cases more unique to LoadSpring's hosting style, but because we host older applications, some of those older applications have not received updated patches from the vendors to remove older SSL versions. We see this a lot with things like Contract Manager. We see it with P6 and some of those older versions. And so what can happen if they're using this older version, and you have something like a Heartbleed that compromises the integrity of that SSL certificate. In that event, the attacker can pose as a legitimate website, and oftentimes what they'll do is they'll execute what's called a man-in-the-middle attack. So they'll appear as a valid site. They'll pass that attack information through from the user. They'll pass that information to our website, but they're sitting there in the middle capturing all of the information that's passing back and forth. So if they successfully do this, they can capture credentials because that information would pass through their malicious website, or it could allow the attacker to gather the information passively. So they can just suck up all of the session data that the users are doing and reconstruct the information that user had put in. And that could give them a competitive advantage, or just give them access to know what's going on with your systems. So the key ways that we protect against this, again, penetration testing. So we're validating, are any of the applications that we host vulnerable to this? Restricting the access to that across the MPLS is going to significantly reduce the likelihood of a man in the middle, because they can't execute, or with that direct connection into our system, they're not able to get in the middle of it. Another key way that we protect against this is with what we call SSL offloading. So with our SSL offloading, what we're able to do is the application that supports the older version and that the vendor hasn't provided a patch for, which we saw with the Heartbleed, particularly with these Oracle applications, we put another layer of defense in place and put a stronger certificate with only the newest TLS versions that are allowed in the middle there, so that it re-encrypts that traffic with that stronger encryption set, and that allows us to circumvent some of the challenges that we see with hosting these older applications. Federated authentication is another way that helps, because it does not allow them to capture those session credentials because of that secure token. And then patching, if a patch is available, then it's critical that we patch that as quickly as possible. So, when we saw the Heartbleed type of vulnerabilities, quickly going through and patching anything where a patch was available allowed us to close that risk for a lot of those applications. The final one that I'm going to talk about here today is ransomware. So ransomware is something that's really been big in the media here lately, and for good reason. It exploits a vulnerability in a website. So if you think about how many patches Oracle released, for example, last quarter, right? Over 270 patches in the last quarter alone. Some of those being deemed extremely critical, with allowing attackers to execute remotely code against those websites. We saw with a lot of the early attacks, like the one against the San Francisco municipal transportation system, that attack actually came in through P6 EPPN, through a vulnerability that was in that particular application. And what would happen when a ransomware attack hits your data is it actually begins to encrypt all of your data. So it uses one of the security teams, security likes to encrypt their data. So it's using one of those tools against us, but it's encrypting all of your data and locking it down so you lose access to it. And so they estimate that it takes between 33 and 72 hours to recover from a ransomware attack. And that's assuming that you have good backups and have been testing those backups and validating them to make sure that your data integrity is in place. Some people have been paying the ransom, so that ransom could cost you as much as it could be anywhere from $1,000 to $75,000 to get the keys that are supposedly going to unlock your data. Another vendor that we saw that got hit through, I believe, also P6 was the Rudolph Libby. Rudolph Libby was thought that they would be better off paying that $30,000 ransom, and it still took them 3 days to get their systems back up and running. According to Symantec, they saw over 460,000 ransomware attacks within the last year alone, and it's something that's grown over 30% as people have been successful in extracting payments from people. So it's becoming a bigger and bigger risk and threat.
All right,
so
we're going to go ahead and, sorry to cut you off there, Cameron, launch our fourth poll question. How often do you test your backups? All right, answers are coming in. We'll give it a few more seconds here. Okay, we're going to go ahead and close the poll now and share results. Okay, so we have most people here said weekly and then quarterly. Okay. Take it away, Cameron.
All right, thank you. So how do we protect against ransomware? You can see that this one really hits across a lot of areas. So we have a lot of layers of protection in place against this, right? Penetration testing, again, can show you vulnerabilities or weaknesses that exist in the software. Our layered security really comes into play here because those web applications that are vulnerable, we separate those with a physical firewall from your data information. So in the event that a web server ever were to be encrypted, it's very quick and easy to roll back to the latest snapshot of that particular server and experience no data loss because no data is stored on those particular servers. Again, the MPLS and IP restrictions protect against these types of attacks by preventing people from accessing those applications that may have that vulnerability in place. Federated authentication, so requiring in combination with the direct access prevention, prevents users from being able to access those applications before they authenticate. So they're unable to run any of those scripts without having that valid user account. Patching also is extremely critical here if the penetration test comes back and if there is a patch in place. And then backup testing and regular backups, right? How much data can you afford to lose is a very important question to be asking your business owners because a lot of backup schedules are nightly or every 8 hours, and we see some people who can't afford to lose more than 15 minutes worth of data, and so we have backups in place that occur every 15 minutes to make sure that the most amount of data, if something like this were to hit, that they would lose would be that 15 minutes, and they're able to quickly roll back. One of the other challenges that we see with this is also that sometimes the payloads can infiltrate your system and remain dormant for up to a year before they get activated. So one of the ways that we prevent against that is by disallowing the outbound access from any of our servers. So if a payload ever were to get in, it can't phone home and notify the attacker that it successfully penetrated our network, preventing them from then remotely executing or activating that particular payload. So there's a lot of different systems that we have in place to protect against ransomware because it's such an emerging threat here against the integrity of our customers' data and making sure that that integrity remains intact.
Okay, we'll go ahead and launch our last poll here. In the event of an attack, how much data can you afford to lose? All right, see some answers coming in here. Thank you. Give it a few more seconds and then we're going to go ahead and close. All right, we're going to close the poll now. And here are the results. So most attendees here can afford to lose 4 hours compared to 33%, which is a bit more a week's worth. We're going to hide the results now. Take it away, Cameron.
All right. So that concludes this portion of today's webinar. Now I'd like to open it up for questions from anybody here in the audience.
And as a reminder, you can still submit questions via the questions pane on your attendee control panel.
All right, so the first question that we had is, how frequently do you see attacks against LoadSpring? And that's a great question. We see attacks against LoadSpring every day. Most of those attacks are not targeted specifically against LoadSpring. Those attacks are just random scans against our IP address ranges, and they're looking for vulnerabilities or exploits. So they'll look for things like, have you exposed any of your database servers to the internet? Do you have any FTP servers or SFTP servers? Our favorite targets that we see attacks trying to be taken place against. And then anything with a website, they're running common scans against to see, are you vulnerable to any of the latest attacks that has come out, as well as attacks that have taken place or vulnerabilities that are older. A lot of places where we see patches have been out or that get hit or attacked, patches have been out for that particular vulnerability for a number of months, and the sysadmin teams or the security teams at those particular places that got hit have not, for whatever reason, executed that patch against that particular vulnerability. So it's critical that you are staying up to date with your patches, because that's a very common vector. All right, another question here. How does LoadSpring handle ransomware infections? And then secondarily, if I'm individually affected at home, should I pay the ransom? So how does LoadSpring handle ransomware infections? In the event that we were to be impacted by ransomware, one of the first things that we would execute is we quickly isolate that particular box, get it off the network so that it can't infect anything around it. And then depending on that, we're going to most likely just roll that server back to the time period before the infection took place. That allows us to rapidly recover access. Because that server does not have customer data on it, we can quickly restore access, find how that vulnerability got in, and then put a layer of security in place, whether if there's a patch available to patch that server. Otherwise, prevent that attacker from being able to access that website, either through coordinating an IP restriction with the end customer, where we only allow their particular work sites to hit that application and not the general internet, or some other way to restrict the direct access. If you're individually infected at home, what we encourage people to do is make sure you have good offline backups. If you have a good offline backup and you're infected at home and you can recover all of your critical information, just wipe your computer, make sure you patch it and get it up to date, and then use your offline backup to restore that critical data. Obviously, if you were to be, if you had some critical information and it were to get encrypted, it's up to you to determine whether it's worth paying the $100 to $1,000 that they generally ask for an at-home attack. One of the other questions that I saw just come in through here is, are Oracle applications more vulnerable than other applications that you guys host? I think that's a good question. It's got a complex answer to it. And I think the more complex the application is, the more surface area there is for an attack against that application. And what we see is that a lot of these Oracle applications or enterprise applications are very complex. So overall, I wouldn't say that Oracle has necessarily more bugs, but as I highlighted earlier, with over 270 in the last quarter alone, they do have a significant attack surface. And so our teams are constantly going through and evaluating the threat based on the way that we have architected our security to make sure that all of our applications are protected regardless of what that threat may be. So, like for example, we just saw today that there was a threat or a critical patch release for Oracle OIM that would allow attackers to remotely execute code without even authenticating to the OIM service. OIM is not something that we are currently hosting. We have hosted it in the past. But we also go through and evaluate, are there other applications that leverage some of this same structure, the underlying structure that OIM uses, that may benefit from having this patch applied on the WebLogic server, on the Apache servers that are hosting these things. So. I believe that is it for questions here, Christian.
All right, thank you, Cameron, and thank you everyone for attending today's webinar, Protect Your Project Management Applications from Common Attacks. If you have any other questions, please email us at information@loadspring.com, and our experts will get back to you shortly. You will also receive a follow-up email within 24 to 48 hours with the link to view a recording of today's webinar. On behalf of the LoadSpring team, thank you for joining us today and have a great rest of your day.